Okay, let's practice sample questions. I will show how to apply those concepts that I explained in the previous lecture and how much the question actually becomes easier to solve it by applying these kind of concepts directly on the questions. And I will use the sample question from the 2017 free response question, number 3. That is for both A, B, and B, C exam. So I will show the question in this slide as well, and you can actually download the original package from the College Board website. Okay, here is the question. See, we have graph of f prime. That's the important one. We have f prime. The function f is differentiable on the closed interval from -6 to 5 and satisfied f of -2 is 7. So this is our given condition. We'll use it. The graph of f prime, the derivative of f, consists of the semicircle at the center and the 3 line segments as shown in the figure above there. Okay, A, asking about f of x at x equals 6 and -6 and 5. So we have f prime and we need to find out f one step up. So of course we need to using integration. We'll do integral of f prime x to find out f of x, and since we have a graph here, so we use area. Okay, that will be our strategy to solve A. B, on what interval is f increasing? Oh, to find out f increasing, we need to check sine of f prime. We'll have a graph of f prime, so that will be easy. Okay. C, find the absolute minimum. Okay, so to find out absolute minimum, we need to find out the local minimum. Local minimum of f of x first, and then don't forget to check endpoint. So endpoint we know it, f of -6 and f of 5, and local minimum where we can find out the local minimum of f of x by checking f prime, and we can do first derivative test. Of course, since we have a graph of f prime, that will be easy too. Very straightforward. And D, asking f double prime. So from f prime, we can get the f double prime one step down. So how can you go down? Always derivative, differentiation. And since we have a graph, that will be slope. So simply, we just need to find out the slope of this curve at x equal -5 and x equal 3. That becomes so easy. And all questions are very straightforward. Okay, so let me show each steps in detail. Okay, A, we need to find f. Like I just explained in the previous slide, from f prime, we need to find f. So we need to go stair up. Okay, so we need to integral, which will comes from area. And do you remember what I told you from this kind of things? When you need to get f of x from f prime, there's two ways, using antiderivative or using definite integral, which is the fundamental theorem of calculus part 1. Okay, which one we have to go? If you need to find out the function, the mathematical expression of f of x itself, then you need to take the antiderivative and using this information to decide the arbitrary constant. But if you need to find out the value, a numerical value for a certain point of f of x, then you better using the format of definite integral, fundamental theorem of calculus part 1, and this is the case. So for here, this is the clue. So starting from -2, this -2 will be one of the end of the interval of that definite integral. And let's find out f of -6 first. So from -2 to -6, but when you actually make an interval for the integration, you better just giving the smaller number from smaller number to the larger number. That's easier. You can flip it, so it doesn't matter. But for me to make more questions easier, I will put -6 bottom, -2 on top, and this is f prime x dx, and just using fundamental theorem of calculus part 1, that should be f of -2 plus minus f of -6. So to find out f of -6, you need to isolate this one from this equation. That will be f of -2 minus integral -6 -2 f prime x dx. Okay, so what is the f of negative 2? It's given 7. We have 7 here. And now, what is this? This is the area underneath the curve from negative 6 to negative 2. So we need to find out this area, which is just the right triangle. Easy. Half base from negative 6 to negative 2, 4. And height, the y component of this one is 2. So 2, which is a 7 minus 4, which is 3. So we just find out f of negative 6, 3. Okay. Let's continue to find out f of 5. To find out f of 5, okay, so similar things, we can actually build the equation. Here, integral from negative 2 to 5, f prime x dx must be equal to f of 5 minus f of negative 2, and f of 5 must be equal to f of negative 2 plus integral negative to 5 f prime x dx. Okay, we already know that this is the 7, and this one comes from this area from negative 2 to 5. Okay, so here that should be 7 plus, we need a semicircle, pi radius is 2 square, this is semicircle divided by 2, but this one is underneath the x-axis, so that should be negative value. Okay, don't forget that it's negative, and plus the triangle, half base from 2 to 5, which is a 3, and height is 2, so it's a 3 times 2. Okay, so that will be 7. What is this? I'm gonna write down this one first because it's negative. It's just a 3 plus the 3, and this one will be just a negative minus 2 pi. So the answer must be 10 minus 2 pi. This is the value of f of 5. So we just find out another point, f5 is 10 negative 10 minus 2 pi. Okay, so we just need to recognize, oh, we need to find out f of x from f prime x. Oh, then we need to using area because it's one step up. Okay, and when you actually calculate the area, just using definite integral, fundamental theorem of calculus part 1, then we can actually find the point, the value of the point by based on this f of negative 2 equals 7. And when you calculate the area, just if we have area above the x-axis, that's a positive value, negative for the area below the x-axis. Okay, that's everything. So A, we just got the answer for that. Okay, so for the question B, on what interval is f increasing? Oh, we're asking about the f increasing. Okay, to find out f increasing, we need to check sign of f prime, and this f prime must be greater than 0 to make f of x is increasing. Okay, where do we have for the f of f prime x? This graph is f prime x. So for this one, this graph must be above the x-axis, positive, right? So here, here. Okay, so simply we have the f prime vector is above the x-axis from negative 6 to negative 2 and 2 to 5. That's all. So the interval for that is from negative 6 to negative 2 and 2 to 5. That is the simple answer. Okay, but a lot of students actually make a mistake just because they're confused by the shape of this graph. Okay, when you have f prime or f double prime graph, we need to find out the information we need. Okay, don't be confused by the shape of the graph. Okay, we are talking about this increasing, decreasing for f of x, not the f prime, not the f double prime. Okay, so if you actually try to look at the shape of the graph, then you are easily confused by that. Okay, so do not look at the shape of the graph, but just to focus on the information. To find out f increasing, we need f prime. and the sign of f prime must be positive to make f of x increasing. And what does it mean by the positive sign for f prime x? That means if you have a graph of f prime x, the graph must be above the x-axis, below the x. Only position of f prime is important, not the shape of the graph itself. Okay, now move on to question C. Find the absolute minimum value of f. Okay, I briefly explained about the absolute minimum value of f on the first slide. Here, to find out the absolute minimum value of f, we need to find out all the local minimum of f and compare the value with endpoints. Okay, so we need to find out the local minimum first. How can you find out the local minimum f? We need to check f prime x. Easy, because we have a graph of f prime x here. And to find the local minimum f, we may need to first derivative test or second derivative test. Okay, for second derivative test is a concavity checking, but for here, since we already have graph of f prime, checking first derivative test will be easier. Okay, first derivative test is find out all the points make f prime equal 0 first. Here, here, here. Okay, so this is end point, we don't need to worry about it. Okay, for these 2 points, we need to check the sign of f prime. So it's above the x-axis or below the x-axis around this point. So here, above, below, below, above. This positive negative sign tells f of x is increasing or decreasing. So the shape of the graph at around here for f of x should be increasing, decreasing, and this point decreasing, increasing. We can find out this one from the sign of f prime. Okay, to be a local minimum should be decreasing, increasing. So we have local minimum at this point. This point should be local maximum. So here we found the local minimum at x equal 2, f of 2. And now here, do not forget about endpoint. Here, f of negative 6 and f of 5. Oh, we found these 2 points from A. Okay, f of negative 6 was 3 and f of 5 was 10 minus 2 pi. Now we need to find out f of 2 only. Okay, since I already know the point, the value at 5, which is 10 minus 2 pi, I will use this value to decide this f of 2. Same thing, the definite integral. Integral from 2 to 5 f of f prime x dx must be equal to f of 5 minus f of 2. So f of 2 must be f of 5 minus 2 to 5 f prime x dx. This is the area from 5 to 5. That is the area of that triangle. Do you remember that area of that triangle was half times 3 times 2, which is 3. So that is 10 minus 2 pi for f5 here, and minus 3. So that becomes a 7 minus 2 pi. So we have 7 minus 2 pi. The question asks to find the absolute minimum. So this is the absolute minimum. So absolute minimum of f is a 7 minus 2 pi when at x equal 2. Okay, that's what we found for C. Easy, right? Okay, for last question, D. D asks about f double prime. Okay, we have f prime, and the question asks about f double prime. Differentiation from the graph, that must be slope. So to find out f double prime value at negative 5 here, so we need to find the slope at this point. And at x equal 3, we need to find out slope at this point. Just clearly, this one shows this is the peak. Okay, on the peak, we don't have any tangent line, so we cannot define the tangent line. The value of f double prime will be undefined, does not exist. Okay, but for the free response question, how can we actually express that one is also important. Okay, see, f double prime is negative 5. So here, f double prime at x equal negative 5, that should be slope of this line. So that will be f of negative 2 minus f of negative 6 over negative 2 minus negative 6. So you can actually write down this way for the free response question to show your work in detail, and that is just 2 minus 0 over 4. So that is just so it should be 0 minus 2, so it's negative half. That's the value for f double prime x negative 5. And for negative double prime 3, so this graph clearly shows it doesn't have any tangent line, so we cannot define the slope of that tangent line, which is the f double prime 3 on this graph of f prime x. Okay, and how can we show it? We need to show this left-hand limit for the slope and right-hand limit of the slope are not equal each other. That's the thing that we need to show to prove the f double prime 3 does not exist. So limit x go to 3 f prime x, that is the slope from the left side at x equals 3. That should be 1, 2, so 2 by 1 is 2, and limit x approaching to f prime x from right side, this is the line that we need to take the slope, which is the negative 1, so they are not same each other, so therefore f double prime 3 does not exist. Okay, so we can answer that way. Okay, so if this is a multiple choice question, by looking at the graph itself, we can just right away find out that f double prime 3 shouldn't exist there. Okay, but to find out the actual how to explain that one for the free response question, this is the thing that you have to show to prove there is no value for double prime 3. Okay. So like I just showed on this all from A to D, those questions sounds very straightforward, right? So there is no difficult and horrible calculation for that. Okay, once you recognize this one is a from f prime to f or f prime to double prime, okay, we need integration or differentiation. Once you recognize that one, or from the graph, I need area or slope. If we recognize these kind of stair structure, then everything becomes straightforward. Rest of them just a technique. Okay. Okay. So following video, you can find out another sample question. Okay. So another same thing, the similar things. I will apply the same thing to show how the question is smoothly go to find out the answer. Okay.